Hi, welcome to Nomis Academy. Today we are looking at integration by partial fraction. Alright, there are different forms of partial fraction, but in this video we are going to consider one of the partial fraction. Okay, now when a rational expression is not in the standard integral form, the only thing we can do is to resolve that fraction, which is called a composite fraction, into partial fraction. And that will make the partial fraction to be in the standard integral form. And then we integrate from there. Now let's pick the first example so that you understand what I'm saying. Example 1. Evaluate integral of 4x minus 5 all over x plus 1 and x minus 2 dx. Okay, now this is an integral. The rational expression we have here is not in the standard form. So this is also called a composite fraction. We can resolve this composite fraction and that will give us a partial fraction which we can easily integrate. Now the first thing to do here is to resolve the partial or the composite fraction to a partial fraction. So let's pick it out. 4x minus 5 all over x plus 1 and x minus 2. Okay, now we are going to resolve this into partial fraction. Since we have product of two linear factors, we can write the expression in this form: a all over the first linear factor, which is x plus 1, and then plus b, then the second linear factor, which is x minus 2. All right. By the time we are done looking for the value of a and b, then we can now proceed with the integral. All right, so let's go ahead to find a and b. Now, we can say that 4x minus 5 is the same with a multiplied by x minus 2 plus b multiplied by x plus 1. All right. Then we proceed by saying 4x minus 5 equal to ax minus 2a plus bx plus b. All right. So here we have 4x minus 5 equal to, collect like term, here we have this ax plus bx, that will be a plus b x. When you add up ax plus bx, we have this, and then the next one we have minus 2a plus b. Now we can compare coefficients of x. So you can see that the coefficient of x in this place, 4 is equal to a plus b. So we write in the other side, a plus b is equal to 4. That is when you compare the coefficient. Let me write it out so that you know what we are actually doing. We say compare coefficients. All right, so we have a plus b, which is equal to 4, and then we also have minus 2a plus b is equal to minus 5. So we can pick this as equation 1, pick this as equation 2. Now, I hope you are familiar with the method of elimination. That's elimination method in solving simultaneous equation. All right, let's use the method. We are going to subtract equation 1 from equation 2, meaning equation 2 minus equation 1. So here we have minus 2a minus a, and that will give us minus 3a. b minus b is 0. The idea is to eliminate b so that we can find a. So b is out. Now we have minus 5 minus 4. That will give us minus 9. So you can see when you divide both sides by minus 3, divide both sides by minus 3, a is equal to 3. So that's the value of a. Then we go further to find b. Now let's put in equation 1. Put in equation 1. So since a is 3, we put 3 plus b equal to 4. So our b is equal to 4 minus 3. Our b is 1. A is 3, b is 1. So we go back to the fraction, the composite fraction, where we say that 4x minus 5 all over x plus 1 and x minus 2 is equal to a is 3. So we have 3 over x plus 1 plus b is 1 all over x minus 2. So we have resolved the composite fraction into partial fraction. Now you can see that the partial fraction is in the standard form, the standard integral form. So it is very much easy to integrate a fraction of this form. Alright, so now let's put that in the integral. So we have, let me clean from here. So we have integral of, I'm going to write the partial fraction, integral of 3 over x plus 1 dx plus integral of 1 all over x minus 2 dx. So very much easy to integrate this. Now when you do that, remember the standard integral that says that integral of 1 over x dx is equal to ln x plus c. So if you remember this standard integral, we can actually solve this. And then look at the denominator. When you differentiate the denominator, you can only get 1 as the derivative of the denominator. So we can proceed from there. So we can proceed to get our final answer. So we have the integral of 3 all over x plus 1 dx is 3 ln x plus 1. Then here we have plus integral of 1 all over x minus 2 is ln x minus 2 plus c. So you can take this as the final result, or you can still go further to simplify. When you bring this here, or let's just pick the whole thing. Remember the multiplication law of logarithm. Remember ln is same thing as log, the natural log. So we have it to be ln of x plus 1 cube multiplied by x minus 2 plus c. So this can also be the final solution to the problem given. All right. Thank you for watching. See you next time. Bye.